Let's look at the concept of transitive. A relation R in a set A is called transitive if A1, A2, if it belongs to R, A2 and A3 also belongs to R, implies A1 and A3 should belong to R. Let me explain the following with the help of a color code. See, first thing is we need to observe between the first and the second order pair, there is something common. There is a common element. Yes, it is A2 that is common. Now, A1 from the first set and A3 from the second set should also be related in the same order, A1, A3. If it is so, it is transitive. Let me again go through this with a different set of variables. A and B are related, B and C are related. So here B is the common variable element. A from the first and C from the second should be related under the relationship R. That's it. That's what they're talking about. Let me explain this with an example. So we have set R, which going to pick up order pair wherein A and B have a difference which is divisible by 3. Let me give an example. It's quite simple itself, but I would like to proceed post an example. So the difference between this is minus 12 and minus 12 is divisible by 3, right? So with all of this set as an input set, let's look at the possibility. Let's look at all the possible pairs and try to figure out what exactly is transitive. So you guys have to observe the numbers and check if the relationship hold good. It is divisible by 3. So pretty much, not pretty much, all the one which are selected are divisible by 3. 7 and 7 difference is 0, it is divisible by 3. 9 and 12, the difference is 3, divisible by 3. Now, what it tells is if I pick up an order pair like 7 and 10, then 10 and 16. So here 10 is common. The first element of the first pair and the second element of the second pair, 7 and 16, has to be related. They are related. Where is it? 7 and 16. Let's pick up some other value. 9 and 12. 12 and 21. So 12 is the common element. So 9 and 21 has to be related. It is related. Let me pick up 21 and 9. 9 and 12. So 9 is the common element. 21 from the first set and 12 from the second set. 21, 12 is also related. And so all of this particular relation is transitive. So let me put up this on the slide as well. So we have say 9 and 12, and then let me kind of link this 12 to back to 12 itself, and say I have to pick up something which is related to 12, say 12 and 21. So by default 9 and 21 will be related. Agree? So this relation is transitive. This is said to be transitive. Let me pick up an example which is a good example actually, where things are not transitive. So we have L set of all lines in a plane and R be the relation in L defined as, so the relationship is such that it will pick up order pair. So L is perpendicular to L2. The condition being L should be perpendicular to L2. So we have few lines and say this is perpendicular, say this is perpendicular, this is, and say this is. So this is the first line L, M, N, and I think this T. So let me change the variable. Let me call this as A. So from the figure, what can we tell? A is related to M, as A is perpendicular to M. Then M is perpendicular to N, right? M is perpendicular to N. So in this too, M and M is common. So I have to pick up, is A perpendicular to n? Is this possible? What is it? Clearly not. A is parallel to n, right? No, answer is clearly no, as A is parallel to n. This again can be explained with alternative interior angles being equated to 90 degree. So there are many examples. I like this example, so yeah, I'm putting it across. Please pause, think over. It's not that hard, but it's the hardest amongst the three, to be honest. So think over. It's not too hard if you understand it systematically.